On today's episode, we're going to find the best way to add threads to your 3D printed part. Here at Avid Product Development, we don't just print parts, we engineer solutions. The engineering team brings years of design expertise to every build, so your product works first time and every time. Today, we're going to use our Mark X load frame to answer a simple but critical question. What's the best way to add threaded fasteners to a 3D printed part? So the engineering team came up with a really cool design here. We have 10 different types of threaded fasteners, and we have a 5% undersize, a nominal size, and a 5% oversize for each option. This is going to give us the full range of how printing tolerances can affect your threaded fastener. So at the top here, we have a hex nut inserted from the back side of the part. This is just a standard nut that you would find at your local hardware store. Below that, we have a plastite screw. This is a type of screw that's specifically designed to thread into plastic, but this is otherwise a smooth bore hole. Below that, we have a nominal tap drill size and then threads printed directly. So you would model those threads directly in your CAD software and then print those threads. Below that, we have a hex press-in insert. So this is pressed in directly without using any heat. Below that, we have a self-tapping insert, so similar to the screw. This is threaded into the part, and the threads on the outside cut into the plastic, and there's these small grooves that stop the part from coming back out. But otherwise, it's an M4 thread on the inside. The next three are a normal heat set insert, so these are installed into the part using heat, such as a soldering iron. We have a short, a long, and then a long inserted from the backside. And then finally here at the bottom, this is what's called a screw to expand. So this is pressed into the part by hand, and there's a small cut on the side of the part that allows this insert to slightly compress and then is then expanded when a screw is inserted into it. So now we're going to install this fixture into the Mark X load frame. Then we're going to use the crosshead here to pull screws out of each one of these inserts and record the maximum force. So we've got our fixture set up in the Mark X load frame. Starting with the threaded fixture here at the bottom, we have a steel reinforcement plate above that. This is going to help isolate all the forces and deflection from the plate while we're pulling the inserts out. We have our M4 screw in there. Then we've got this part here that's going to pull on just the head of the screw. That's in an auto tightening chuck within the larger load frame here. We're going to pull on each one of these one by one and log the maximum force within the machine. With that stuff out of the way, let's get the testing started. We finished all the testing, so let's dive into the results. Starting at the top here, we have the hex nut from the backside. This is a great, very strong solution, but it does require quite a bit of space and access to the backside of the part. Below that is the plastite screw. This is an awesome option and one of the strongest forces, and doesn't require any access from the backside. Below that, we have our tap drill and the printed threads. This is the smallest overall footprint, but does offer relatively low force compared to some of the other options. A critical thing to note with the plastite and the other two plastic threads is that they don't work well over time. As you remove and reinstall fasteners, they tend to wear out and can often strip out. The twist-resistant hex press-in has relatively low force and takes up quite a bit of space in your part. The brass thread-in has higher force than the hex and takes up less space within your part. And then we get into the heat set inserts. The short heat set insert offers relatively low force compared to the other two, but also takes up much less space and offers a very reliable fastening method. The long heat set from the front offers noticeably better performance than the short, but does require about twice as much depth within your part. And then one of the best heat set options is the long heat set insert installed from the backside. This has one of the highest forces, but does require access from the backside of your part. And then finally at the bottom, we have the brass screw to expand option. This has one of the lowest overall forces in the test and is not one that we really recommend. Thanks for watching today's video. For a summary of today's test results, there's a link in the description. If you have any questions about the results, hit us up in the comments below. If you found this video valuable, hit that like button and subscribe to stay tuned for future episodes. We'll see you in the next one.